Good morning to all. In this session, we are going to discuss orthogonality principles of signals. This is a part of Unit 2. Now, Unit 2 is still continuing. Let us start. Now, let us start. Now, in this session, we are going to discuss orthogonality principles of signals. Orthogonality principles of signals. Orthogonality properties of signals. Now just look at. In this one, we are going to discuss 4 important orthogonality principles. Very important. Students have to very much remember this one. Principle 1. Any two harmonics with different frequencies, and phase values, are orthogonal. They are orthogonal. Very much important. Now just look at any two harmonics. That means any two signals. You take any two signals with the different frequencies and phase values are orthogonal. Here phase value is called angle. In mathematics notation we use the word angle. Here we use phase value. For example, just look at. That means what? For example, x1 of t is one signal, x2 of t is another signal with different frequencies and phase values. Then over a given time period t1, t2, here one more point, some others may use the period like 0 to t. Anything you can use, no need to worry. t1 to t2, then x1 of t and x2 of t dt, its value is equal to 0. This thing you have to observe very carefully. No need to need any proofs, direct principles. Any two signals are we call harmonics. Any two signals with different frequencies and phase values are always orthogonal. Orthogonality means what? Multiplying two signals and integrate between the given time period, you should get 0. That is orthogonality principle. For example, just look at. You look at one signal. The signal equal, for example, to 2 omega t. You can make it 2 omega naught t plus some pi by 6. Some pi 5 by 6. You take another signal. For example, 3 times sine 4 omega naught n t plus pi by 81 or pi by 8. nt. Now just look at. One signal is given. Amplitude is 2 times. Amplitude is 2. The given signal is a sinusoidal signal. The frequency is 2 omega naught nt. Phase value pi by 6. Another signal is given. Amplitude is 3. Sinusoidal. This is also a sinusoidal signal. But the frequency is 2 omega naught nt. Here the frequency is 4 omega naught nt. Phase values pi by 6, pi by 6. Different. That means what? For the signal x1 of t, frequency is what? 2 omega naught n t. Phase value is equal to pi by 6. Amplitude that is equal to 2. Just look at, you can make an analysis upon this signal. Now, for the second signal, x2 of t, x2 of t, that is equal to frequency is equal to, what is the frequency? 4 omega naught n t. What is the phase value? Phase value equal to here pi by 8, and here amplitude is equal to 3. Amplitude cannot be taken into consideration. It is not an important parameter. But what are the important parameters? Frequencies. How many number of signals are given? 2 signals are given. Both signals are what? Sinusoidal signals. But even though both are sinusoidal, look at frequency 2 omega naught nt. Here 4 omega naught nt. Different. Here phase value. Phase value means angle. Pi by 6. Here pi by 8. Amplitude, no need to take into consideration. For your understanding purpose only, just I have written amplitude. So here frequency of x1t is not equal to frequency of x2t. Next, phase value of x1t is not equal to x2 of t. Therefore, these two signals should be orthogonal. These two should be orthogonal. These two should be orthogonal. Orthogonality means what? These two should be orthogonal. This implies over a given time period T1 to T2, the given signal, multiply these two signals. What is the 2? This into 2 into this, 6. 6 is a constant. You can make 6 outside. This implies sine 2 omega naught nt plus pi by 6 into sine 4 omega naught nt plus pi by 8. With respect to dt, its value should be 0. No need to make 2 sin A sin B formula, and no need to make any expansion. No need to integrate between T1, T2 given time period without making any mathematical calculations. Directly just we will be able to tell the response output of these two multiplication of these two signals. Output is 0. This is one of the orthogonal property. So if any two signals are given, if these two are orthogonal or not, if these two are orthogonal, by what process we made here? Just we didn't make any calculation. Just we categorized what is the frequency of this signal and this signal. What is the phase value of this signal? This signal. What is amplitude? This signal, this signal. But amplitude cannot be a parameter. The main parameters of this calculation is only frequencies and phase values. So you take any two signals. First, you have to observe that are these two having different frequencies and different phase values. Then multiplying these two over the given time period, it should be 0. That is the first principle of orthogonality. That's why orthogonal principles on signals or off signals. This is very much important. Again, just I am repeating this concept. You take any two signals, we call it as harmonics. Why do we call harmonics? In the Fourier series, I will explain this one. So any two harmonics with different frequencies and phase values are always orthogonal. Orthogonality means ultimately you have to prove that it is 0. Multiplying these two signals and integrating upon this one. Here one important point, here in these problems we used T. What is the fundamental period? 2p is 2 pi by omega naught. Just look at this formula is very much important. You know the same formula since your simple harmonic motion concept in intermediate physics. Now here T is called what? T is fundamental period. T is called what? Fundamental period. You called T. T is called fundamental period. T is called fundamental period. Here omega naught. Omega naught is called fundamental frequency. Look at the words fundamental. It is called fundamental frequency. Omega naught is called fundamental frequency. Students have to remember this one. The formula is what? T equal to 2 pi by omega naught. The same thing, just you can write it. If T equal to 2 pi by omega naught, then omega naught will also be written as 2 pi by T. These two are same by T. So T equal to 2 pi by omega naught, or you can make it, you can make swap omega naught here, T here, another principle. Both are same. But in this one concept, you are very much particular about the first property. What are the first property? Any two harmonics signals with two different frequencies and phase values are always orthogonal. That's the first principle. In this one, again, wherever we mention the representation omega naught means what? Students have to replace omega naught by 2 pi by T. Frequency 2 pi by T. So whether you write this formula or this formula, both are same. Now, in the next session, now just we are going to discuss the remaining three principles. Thank you.